ADALINE, which stands for Adaptive Linear Neuron, is an influential neural network model that was developed in 1960 by Bernard Widrow and Marcian Hoff at Stanford University. ADALINE represents an important milestone in the early development of artificial neural networks and machine learning algorithms. It introduced the concept of adaptive learning, paving the way for more advanced models and algorithms in the field. The ADALINE model is a single-layer neural network that operates as a linear classifier. It consists of an input layer, a linear combination unit, an activation function, and an output unit. The input layer receives input features, which are multiplied by adjustable weights and summed up in the linear combination unit. The resulting weighted sum is then passed through an activation function to produce the network's output. The key innovation of ADALINE lies in its learning algorithm, known as the Widrow-Hoff rule or the delta rule. The learning algorithm allows ADALINE to adjust its weights iteratively based on the difference between the network's output and the desired target output. The weights are updated in a way that minimizes the error between the actual output and the target output, using gradient descent optimization. The learning rule of ADALINE can be summarized as follows: for each input sample, the output is computed based on the current weights. The error, which is the difference between the computed output and the desired target output, is then used to update the weights. The weight update is proportional to the input value and the error, and it is performed in the direction that reduces the error. This iterative weight adjustment process continues until the network's performance reaches a satisfactory level. One of the notable features of ADALINE is its linear activation function. The linear activation function provides a continuous output that is directly proportional to the weighted sum of the inputs. This linear behavior allows ADALINE to model linear relationships between inputs and outputs. However, it also limits its capabilities in capturing nonlinear patterns in the data. ADALINE was initially developed for pattern recognition and pattern classification tasks. It demonstrated promising results in various applications, including speech recognition, image processing, and adaptive filtering. The model's ability to adapt its weights based on training examples made it suitable for dealing with noisy or dynamically changing environments. ADALINE's impact on the field of machine learning and neural networks was significant. It laid the foundation for subsequent advancements in adaptive learning algorithms and neural network architectures. The model's simplicity and effectiveness in linear pattern classification tasks inspired further research in the development of more complex neural networks capable of handling nonlinear problems. The development of ADALINE also led to the introduction of the concept of backpropagation, which is a widely used learning algorithm in modern neural networks. Backpropagation, first introduced by Paul Werbos in the early 1970s, is an extension of the ADALINE learning rule that allows for the training of multi-layer neural networks. ADALINE's success and its impact on the field can be attributed to its ability to learn from examples and adapt its weights to improve performance. This adaptive learning mechanism became a fundamental concept in machine learning and artificial neural networks. It opened up new avenues for developing more advanced algorithms that could learn from data and automatically adjust their internal parameters to optimize performance. In conclusion, ADALINE, developed in 1960 by Bernard Widrow and Marcian Hoff, is a significant contribution to the field of artificial neural networks and machine learning. Its adaptive learning algorithm and linear activation function marked important milestones in the development of neural network models. ADALINE's success and influence paved the way for future advancements in the field, inspiring the development of more sophisticated neural network architectures and learning algorithms. Today, ADALINE's principles continue to underpin many machine learning algorithms, serving as the foundation for modern neural network models used in a wide range of applications.